All right, we're going to continue in chapter 1 here, and we're going to be doing now matter. Okay. So before we go very far here, we probably should discuss what is chemistry. And chemistry is simply the study of matter. The properties of matter, how matter interacts with other matter, the energy associated with these interactions, and how energy affects matter. So basically everything in the universe is matter or energy. So what is matter? Matter is simply anything that has mass and volume. Anything. And some of these things we can see, and some of these things we can't see because they're too small. So matter is basically everything that surrounds us: air, water, ground, whatever. Anything that has mass and volume is matter. We use the term substance as a general term when we are discussing specific types of matter. Okay? Like a certain substance, like water is a substance, or the air is a substance. So it's just a term we use when we're talking about a specific type of matter. So matter exists in 3 primary states: solid, liquid, and gas. Some matter is too small to see, which we call, when it's at that level, we call that the microscopic scale. You need a microscope to see it. And stuff that we can see is at the macroscopic scale. Macro means large. You can see the picture here in the slide where we've got a depiction of a container that has a solid in it, a container that has a liquid in it, a container that has a gas in it. You can see the solid sits at the bottom of the container, kind of in a pile, and the image under that shows kind of the atoms or molecules in the solid that are all very structured. They're all ordered, right? They have a specific place, and they're in that place. In a liquid, you can see that the particles are still very close together, but now they're much more randomized. There's no specific place for them. They can move around each other, but they stay still pretty close to each other. And then in the gas phase, the molecules now have separated quite a bit. They're randomly moving around. They fill the container completely. So that's the fundamental difference between solid, liquid, and gas. Now, the main thing that's occurring here is that there's attraction between these particles. So all those particles that are depicted by those orange spheres, they're attracted to each other. So when the spheres don't have much energy, when the particles don't have much energy, they're solid. They stick together because they're attracted to each other. If you give them a little bit of energy, in this case we raise the temperature. We raise the temperature a little bit. The molecules or particles get more energy, and that energy allows them to pull apart from each other a little bit. All right? So in the liquid phase, now the energy of the particles and the attraction between them is pretty similar, so that they can pull apart, but they can't pull apart too far because there's still a lot of attraction. But now they have enough energy to move around each other. So we went from a solid to a liquid. That's melting, right? And then if we go from the liquid to a gas, we give them more energy. So we increase the temperature more, and at some point they evaporate, and the particles now have completely overcome the attraction because they have so much energy. They have more energy than the attractive forces between them, and now they can move around each other freely and move away from each other freely, right? So the main difference in all these is the amount of energy the particle has, and the ability that energy has to overcome the attractive forces that naturally occur between particles. So we can think about how our body or humans or whatever uses the different phases, right? To survive, we have to intake oxygen, and we do that by breathing. And we we inhale the oxygen, it ends up in our lungs, and our lungs absorb the oxygen. The oxygen is a gas. And we can, if we're working out or we're walking upstairs or something, we breathe faster so that we can inhale more oxygen quicker, so it can get to our muscles and let us do the work we're doing. The oxygen that's absorbed by the lungs is transported through the body through blood. Blood's a liquid. It flows through the body. Oxygen is transported to the different organs and organelles in our body that need the oxygen. It's carried through by hemoglobin, which we'll talk a little bit about later in the semester. The ability that the blood has to flow quickly through our body and interact with the organs in our body to deposit oxygen there, it's critical that's a liquid. And then a lot of our body has solid, right? So the organs in our body are considered solids. Our skin, heart, lungs, liver, brain, those are all considered solids. We eat a lot of solid food. So every phase of matter is critical to our existence.